So purification of colloid, this part already covered. Then comes to this part that properties of colloids. There are three type of properties like kinetic properties, optical properties, and electrical properties. First is kinetic properties, which relate to the motion of the particles within the dispersion medium as follows, like a Brownian motion, diffusion, sedimentation, osmotic pressure, and donor membrane effect, viscosity. First is in case of kinetic properties, the study of kinetic properties of colloidal dispersion is very much important to a pharmacist. It is helpful in predicting the stability of a system, determining the molecular weight of the particles, studying the transport kinetics of colloidal particles. So, first, the Brownian motion. Brownian motion is named after the Robert Brown who proposed this theory. The colloidal particles do not sediment because of their smaller size. In other words, particles are in continuous random motion. Brownian motion may be exhibited by particles as large as about 5 micrometer. Thermal energy keeps the particles in motion. They collide with each other and with the wall of the container. This collision changes the direction of velocity of particles. This molecular collision keeps the particles under continuous and random motion. Brownian movement can be viewed by a light microscope. Brownian movement works against the gravitational force. So, as the particle size increases, the velocity of the particles decreases, and slowly the gravitation force starts influencing the motion. Brownian movement can be decreased or stopped by increasing the viscosity of the medium by adding glycerin like material. So here the Brownian motion zigzag like a zigzag pathway, here to here, here to here, then here, then here. The definition will be like that colloidal particles are subjected to random collision with molecules of the dispersion medium like solvent. So each particle move an irregular and complicated zigzag pathway. The velocity of the particle increases with decreasing the particle size and viscosity. Increasing the viscosity of the dispersion medium is done by glycerin, and decrease then stop Brownian motion. Then comes to diffusion. Since the size of colloidal particles is small, this can diffuse through membrane such as porous plug. Diffusion occurs spontaneously. This property permits the estimation of molecular weight of polymers such as egg albumin and hemoglobin. Diffusion is a direct result of Brownian motion. Diffusion can be expressed by Fick's first law, which is dm dt, dm divided by dt equals to minus d multiplied by a into dc by dx, where dm is mass of substances diffusing in time dt across an area a under the influence of concentration gradient dc dx. The minus sign denoted that the diffusion takes place in the direction of decreasing concentration. D is the diffusion coefficient. So this is the diffusion coefficient. A is the surface area. dc by dt. This is the concentration gradient. dm is the mass of substances, and dt is diffusing in time. That means time, difference in time. So as a result of Brownian motion, particles pass or diffuse from region of higher concentration to one with the lower concentration. Here, higher concentration to lower concentration. Solute transport from a left to right movement of the solutes is due to the concentration gradient dc/dx. Viscosity of dispersion is determined by capillary viscometer. Uh, that is equal to volume obtained by density determination. Next is sedimentation. Sedimentation is velocity of sedimentation of spherical particles is obtained by Stokes law. Sedimentation is influenced by the gravitational forces. The lower size limit of 0.5 micrometer for applying the Stokes law. As colloidal dispersion exhibits Brownian motion, gravity sedimentation will be minimal. Sedimentation is not a kinetic property of colloidal system, but itself under normal condition. Therefore, a stronger force must be applied to bring about the sedimentation of particles. Forced sedimentation is made due to estimate the molecular weight of the polymers by preparing a colloidal dispersion. Ultracentrifuge, that means forced sedimentation, is used to study similar properties of drugs, micelle molecular weight of the antibiotic, fusidate sodium, etc. The exact method and mathematical treatment is beyond the scope of this chapter. Here, the Stokes law, V equals to 2r square rho minus rho 0. It is previously I have told this law uh, to the suspension in suspension chapter unit 3 from unit 3, the coarse dispersion. This Stokes law was there. 2r square. This is here r is using not the diameter, it is radius. So v equals to 2r square rho minus rho 0 into g divided by 9n. If it is expressed by d, then d square into rho minus rho 0 into g divided by 18n. If you convert this r to d, that means d equals to 2r, then it will be 18. So v is the velocity of sedimentation of spherical particles. Rho or p is the density of spherical particles. And rho 0 or p0, density of the medium. And the eta or n, this is denoted here for viscosity of the medium. And g is the acceleration due to gravity. At small particle size less than 0.5 micrometer, Brownian motion is significant and tend to prevent sedimentation due to gravity and promote mixing instead. So we use an ultracentrifuge which provides stronger forces, so promote the sedimentation in measurable manner.